Dan?
Okay, well, this week,
Big payoff.
yes, this week is for those of you who have been here all along. Oops, I did it again. The big payoff where you actually get to turn all those lesion drawings and normalization techniques and basic principles into statistical maps that can go into an article, that kind of thing. So for all those people, it seems like a smaller crowd today. For all those people who are missing this, really, it's a wasted effort. So I'm mostly not gonna do slides today because I'm going to actually do analyses. But I just have a few things to mention beforehand. I should, since I said I was going to do it last week, I should tell you what happened with my lesion distorter experiment. And it's not a completely known outcome yet, but I wrote some scripts to take lesion maps and distort them systematically by shrinking them, enlarging them, and shifting them. Usually either shrinking, usually size and shifting in combination, for all the maps in a group, and seeing what effect it had on the statistical maps. And the answer is it had an effect. That's it. So it's not quite a complete. What I'll say is it didn't obviously change the pattern anywhere, but it did result in some apparent loss of sensitivity, or in some cases gains in sensitivity. It just changed the sort of apparent gain on the effects a little bit. I hope to know something a little more systematic about that. It's not quite enough evidence to say that all this careful lesion drawing should be discarded in favor of quick sketches, but it's not enough to say that we shouldn't do that either. Okay, so one of the things I'm going to emphasize today is that when you're doing VLSM analyses, it's important, especially for these analysis things, where you're trying to tease out some subtle statistical effects often, to do things more than one way. And part of the reason to do things more than one way is because different packages of software have their own quirks. I'm going to talk mostly about voxel because that's the package that I wrote, along with some other people who helped me. But of course, there's also MRIcron, which has as part of it NPM, which is a useful package for doing analyses, especially under Windows. There are other packages like R that I think are incredibly valuable and can be used for these kinds of analyses to some extent, although they're not ideal because they don't speak image data. You could probably get SPM to carry out these analyses as well. I'm not suggesting that every analysis has to be carried out in several different software packages, but what I am suggesting is that it's really useful, especially when you're not quite sure if you've gotten all the flags set right for some program, or every little I dotted and T crossed, to try things in more than one package, or at least more than one way in the same package. As you'll see later, Voxpo has two different programs for doing the typical kind of linear regression style analysis that we do in VLSM. And I often find it helpful to try things in both just to make sure that it seems to come out identically when it's supposed to. And I will say one of the reasons that I've been sort of motivated to recommend that is because people often come to me and say, I've run the same analysis in Voxpo and MRIcron and I get different results. Why? And so far the answer to that has invariably been that you thought you were running the same analysis, but you actually weren't. And it's a very easy mistake to make. It's not always transparent in either package exactly what you've done. So I would describe that as a shortcoming of both packages, and just a good reason to run things both ways. I'm also going to try to emphasize staying close to the data, which means a few things. One is running little diagnostics to sort of sanity check the data and what you think should be various intermediate products along the way. This is something that is not at all specific to VLSM. People who do fMRI should be doing the same. Paying close attention to error messages or warning messages to the extent that they're generated by the software, things like that. And it's very easy to send data through a pipeline and have it come out somehow nonsensical at the end, either in an obvious or a non-obvious way. And it's just a little easier to avoid that if you check along the way and make sure that every step seems to be producing what you expected it to. And along the same lines, I'm going to recommend doing things over and over again. This also should be familiar to people who do fMRI, who are constantly realizing they've messed up one step and then have to rerun an entire analysis. And I don't think of this as a bad thing. There are lots of good reasons to be able to do things over and over again. I think two of the most important are auditing, to make sure you know exactly what you've done, reporting so that you can tell other people exactly what you've done, which I guess are the same thing, And a third one, which I didn't put on here, which is tweaking your analyses. If you realize you've done something wrong or that you'd like to try something a different way, it's much easier if you have some kind of script or other system for automating your analyses. So I recommend generally when you embark on VLSM analyses or fMRI analyses or anything, pretend that whatever you're about to do, you're going to have to do 100 times. And I think that will force you to do things in a way that that will sort of satisfy these other needs. And also, it's usually not too far off. And finally, I would recommend that if you're using Voxpo, you subscribe to the Voxpo mailing list and ask questions on there, because that way, when I answer the questions, it won't be just you who benefits, but everyone. No question is too stupid. Frequently people ask questions on the Voxpo mailing list that remind me that I've forgotten about some feature that it has that would be actually more useful to than what I've been recommending. It's almost invariably the case that other people are struggling with the same problems. And I think the same is true for MRI Crow or MRI Cron. Both of these mailing lists are very low volume, and I think they are, however, subscribed to by a large number of people who are interested and who may have answers other than just me and Chris Rorden. And I suspect this is true for Chris as well, that we'd both be happy to have discussions on our mailing lists that extend beyond just asking about features of the software, but that extend to asking general questions about analysis and best practice. So this slide doesn't really mean anything. I was just sort of trying to set out an outline for what I wanted to talk to today, but actually what I really want to talk about is over in this text file, and I'm going to put this text file up on the wiki page at some point. But I'm just going to scroll through this text file really quick just to show what, in terms of commands, a VLSM analysis involves. And you can see that actually just more than half the lines are white space, and these things with pound signs at the front are comments. So there's not a whole lot. These commands are by and large very simple, and we've gotten all the way down here. We've done a lot of sort of redundant work and kind of nonsense. Then down here there's some extra stuff in case you wanted to look at nuisance covariates. But really, very short small amount of code. And what's in this text file is, I call it code, but these are really just command line invocations. They're invocations of maybe a dozen or so different programs in Voxpo that do different parts of the analysis. These aren't necessarily the only ones you'll need. Voxpo has like 130 different programs, and they're all useful for something, and probably about 40 of them are useful for VLSM. It's really important to know what tools are available to you, to sort of have a sense for what kinds of things these tools can do. I'm not saying you need to know what every flag is for. I mean, here's the help screen for one of Voxpo's tools called VBIM, and I wrote this program and I can't remember all the stuff that it does. It's a lot of stuff, but I can find it on here when I need it, and I kind of know what's in there. If you get a sense for what's in there, for what these programs can do, the sort of space of possibilities, it really helps, because then when you need to accomplish something in analysis, you kind of have an idea where to look and what to try. And this does not extend. I mean, this obviously extends to other tools as well. Voxpo, especially the tools that I'm going to emphasize right now, are all command line tools. So we're not going to be clicking on buttons for the most part, except when we want to look at the results. We're going to be typing in commands. And there are lots of good reasons for that. There are also reasons why graphical interfaces would be nicer. The best argument for a graphical interface is that you can sort of sit right down and know what to do right away. But the problem that we usually find with graphical interfaces is that it's not easy to do it again 100 times. Clicking through a graphical interface 100 times is very frustrating and difficult. Other parts of Voxpo have graphical interfaces that you click through, and then they create a little script for you so that the next time you can use the script. The VLSM stuff doesn't quite have that yet. So for the most part, I kind of recommend trying to do things using a little text file like I've done here, and typing out the commands in the text file that you plan to use. So I'm going to remove this demo directory, and I'm going to make a fresh copy of it. Can everybody sort of see that? Or do I need to make the font bigger or anything? I'll pretend no. Okay, so what I've done is I've created this demo directory that has not that much stuff in it, really. It has a bunch of VOI files that I copied from Chris Rorden's MRI Cron package. These are ones that he uses to make a little demonstration. I've renamed them actually because they used to be called things like 1.voi, and I renamed them to o1.voi so that they would alphabetize correctly. So a Windows thing. And I took his continuous variable reference, which you can see over there on the right. The only other things I added to this directory are the AAL atlas, the Brodmann atlas, which I don't know if we'll even want to look at today, and the Colin brain. So this is what we're starting with, and you can see right away this is enough to do a VLSM analysis. We have 24 brains and one dependent variable, and each of these VOI files, we can look at one of them. With VBView 2, each of these VOI files has a lesion in it somewhere. Chris generated these for MRIcron as a demo. He generated them artificially by creating circles, spheres, and masking them with gray matter, I believe. It's useful as anything else to demonstrate how this stuff works anyway. So the first thing we want to do to carry out these analyses in VoxBo is, well, I guess the first thing we should do is just take a quick look at these VOI files and make sure they all look like they're kind of the same dimensions, same kind of data. In fact, they do. They're all nifty 3D files. They all have the same dimensions, same voxel sizes. They're all byte data. If we really wanted to get crazy, we could use VBIM and the -info flag on all of these to find out what the minimum and maximum values are in these files. And we can see for most of them it's a minimum of 0 and a maximum of 255, actually for all of them. So that's interesting. Normally we wouldn't use 255, we'd use 1, but I guess it doesn't matter that much. Next we're going to just smush those together into a test file the way Ola showed you last week. This just takes a moment. You see that I've named the test file lesions.test.gz. For those of you who don't know Linux that well, gz is the suffix for the gzip compression algorithm commonly used on Linux and other Unixes. Lesion data tends to compress extremely well because these are files that have lots and lots of zeros. So even though this has 24 volumes that are actually at very high resolution, this whole lesion file only takes up 159K. If we uncompressed it, it wouldn't take up a whole lot more because the test file format is clever about compressing as well. And we can also do what Ola suggested last week. We can look at the header. I'm using Zmore, which knows how to look at text headers and compressed files. And we can see that these files were indeed included in there in alphabetical order. So that's good. That should correspond to the continuous variable that was included. When you're starting off with VoxBo, or really any program, it's really helpful to look at the command line options for a lot of these things. All the VoxBo programs, except for the ones that have graphical interfaces, but all the command line programs, if you type the name of the program all by itself and hit return, you get a little bit of help. It sort of looks like this. And usually it tells you up here sort of what an invocation of the command looks like, and then here what the different flags are, and then down here some notes on the flags. So I'm not going to go into detail on exactly what the syntax is for all these programs, but that help is readily available. If you find it confusing, email me and I will fix it. But the first thing I'm going to do is just quickly look at the overlap between each of these patients' lesions and the different ROIs in the AAL atlas. I thought I copied that, but I apparently missed. Okay, so I'm